us R sub L.
No. They gave you two volumes.
Oh, sorry, they gave us volume. I was looking at the diagram.
Okay.
They gave you they gave us R sub V.
Which is what?
That is volume.
Well, what is R sub V? What's the ratio?
It's 680.
Yeah, I'm gonna revert back to doing it Yansak's way, little to big, just because I don't want to confuse all the students. Even though
I know. I was saying 686 over.
I firmly believe that big to little works better, but don't have to do it. You can always do little.
I do little to big. I was saying 686 over 3,456.
I know you have, but last time you and I met, I tried to talk you into doing big to little because I thought it made more sense. But then I talked to all of Yansack students, and he insists upon doing little to big, so I'm not going to change it around. So what's the next thing I can figure out? Can I figure out the linear? In other words, what they're asking for is the linear ratio.
If that has a proper square root.
It's not a square root. What's the linear ratio going to be?
Cube root, sorry.
Okay. Do you know how to take the cube root of this ratio?
Yes.
What is it?
Well,
your best
right now I would have to reduce.
Your best bet is probably to take the cube root of the numerator, which I bet is an integer, and the cube root of the denominator, which is probably also an integer.
Well, he wants us to reduce it into a cube root.
Okay, here's what we're doing. R sub L is the cube root.
Wait, but think about it. Wait, I know.
That's what R sub L is. Let's figure out what that is.
Wait. But I do know, if my calculator would work, I do know that 343, the cube root of 343 is 7. So, and that is 1/2 of 686. So if I do the same thing for 3,456, I can get the ratio.
Okay, well, you have to use a calculator one way or the other here. Do you have your calculator in front of you?
Yes.
Take the cube root of that ratio.
Give me a second.
And use the math feature that converts it to a fraction, because there's nothing wrong with a decimal answer, but it's more confusing.
Okay, over. Equals R sub L equals 7 over 12. 7 squared is 49. And then, so I have my ratios. The ratio of R sub L is 7 over 12. Ratio of R sub A is 49 over 144. And then R sub V is 343 over 1728.
Okay. Now answer what x is. Set up the ratio that will solve for x.
Okay. So we're trying to find the R sub L, right?
Well, we already found it. That's 7 over 12.
So what we already have is the ratio for length. So all we need to do is, since we know that 24 is the bigger number, we have to make that equivalent. So 7 over 12 equals 20x over 24.
Good.
And I already know from just mental math that it reduces to 1/2, so x must equal 14.
Right. Okay. Let's look at the next problem. What do they give us? In other words, all of these problems begin with these three ratios. And they usually give you one of the ratios. And then you have to calculate the other two. Which ratio do they give us here?
Give me a second. Okay, they give us the surface area ratio.
Which is what?
Which is 192 over 363.
Yeah, and it's okay to omit the pi because they cancel. In other words, that's the correct ratio. Now, how do I get the volume ratio from that ratio? Because they're asking about volume, so I'm going to need a volume ratio. And this is the trickiest of these problems.
What we do is we square that.
Square it or take the square root of it?
We find the square root of that and then cube the square root.
Well, guess what? That's the same as doing this. In other words, you don't necessarily have to go down and figure out R sub L. They don't ask any linear question here. The only thing we need is the volume ratio. Now, you can get that from the area ratio by, instead of taking the square root of it and then cubing it, oh, I got it backwards here, excuse me. I need to do it that way. In other words, when I take it to the 3/2 power, what I'm doing is taking the square root of it, which gives you the linear ratio, and then I'm cubing that, and that gives you the volume ratio. So you can actually avoid a step of going backwards by just doing it this way, but just make sure you don't make the mistake I just made. You know how to do this in your calculator? Just put 192 divided by 363 raised to the 3/2 power, like that?
Yes.
Go ahead and do that and tell me what.
To find these ratios, Mr. Gansack wants us to get perfect squares for the ratios.
Okay.
So we don't have integers. So what I'm mainly trying to do is reduce the fraction, because it certainly has a perfect square. And I found it. It's 64 over 121. That's 1/3, and then that reduces to 8 over 11. And then I can...
For what, are you talking about the linear ratio or the volume ratio?
The volume, no, the linear ratio is 8 over 11, and then the volume ratio would have to be 512 over 1,331.
What's the bottom?
What?
What's the denominator? I didn't hear.
The denominator of the 1,331.
Okay. Now, let me show you a shortcut. You did a lot of work there to get the same thing you would get as if you just put this into your calculator. Put 192 divided by 363 and raise that whole thing to the 3/2 power. You'll get this ratio.
Oh my god, my calculator is crap.
Meaning it's not working, or?
The thing about my calculator is it'll give decimals.
Do you have a key on there that switches the decimal to a fraction?
Right now I'm not using my graphing calculator.
Okay.
Because it's not exactly as versatile in this.
Okay.
Right now I'm just using a bad calculator that I need to delete because it's just terrible.
Now you see why I prefer big to little. Notice that if you have big to little and you take the square root of it, it stays a number greater than 1. When you're dealing with all of these fractions where we have little to big, all of these numbers are less than 1. And when you start taking square roots and cube roots and 3/2 roots and 2/3 roots of numbers that are less than 1, it's hard to figure out what ballpark they should be in. Because most people don't realize that when you take the square root of a number less than 1, it gets bigger. When you take the square root of 1/2, it's excuse me, when you take the square root of 1/4, it's 1/2 is the answer. Whereas it got bigger. If I took the square root of 4, it's 2. That gets smaller. Most people are used to taking square roots and having the answer get smaller. So the moment you are forced to go little to big, all of a sudden you have all of these fractions that you have to take square and cube roots of. And when you do it on your calculator, it gives you decimal. Well, there's no problem with decimal. We can handle decimal. Actually, we don't need any more. You got it all. Is this the correct volume ratio?
What? Yes, it is the correct volume ratio.
So now let's answer the problem. Forget my little shortcut. If your calculator is not working, you're not really going to be able to do that shortcut.
So I've already plugged the numbers in, and for the volume, I've got 2,560 pi centimeters cubed.
Which is about a third. This is about a third. Okay, good. That sounds like a reasonable answer. Number 4.
Okay. The weight of two similar ingots of gold are in the ratio of 500, 2,916. If the surface area of the smaller ingot is 200 inches squared, find the surface area of the larger ingot.
So what did they give you in that first sentence? Which ratio is that?
500 to 2,916.
Yeah, but is that a linear area or volume ratio?
That's volume.
Well, it's actually a weight, is it not? It's the weights. But you're correct, because gold is uniform. When they give you the weight ratio, they are in effect giving you the volume ratio. Okay? So the volume ratio is 500 is to 29. Is that a 16 or an 18?
What?
Is that number 2916 or 2918? I can't read it.
That's 2916.
Okay. Now they're asking about area. So I got to get an area ratio. And again, let's just get the linear ratio and then we'll square it to get the area ratio. We'll do it the hard way. So what's the linear ratio?
Okay. 500 cube root. It's 7.937. That's why I can't stand this calculator.
Well, and that's not the right answer either, because that's a number greater than 1. Our answer has to be a number less than 1. So here's what you do. Can you take cube roots on that calculator you got?
Yes.
Take the cube root of that whole ratio, or just take the cube root of the numerator and then the cube root of the denominator. What's the cube root of 500?
The cube root of 500 is 7.937.
What's the cube root of 2916? You're not really going to be able to do these problems with that calculator.
Yeah, no, I'm going to delete it right now. Because it's absolute trash.
We don't want these decimals. We want fractions. Okay, here.
Give me a second, I need to grab my graphing calculator.
Okay, good. Now let me show you how to put it into your graphing calculator. In one step, I'm going to do in parentheses 500 divided by 2916. I'm going to take that quantity and I'm going to raise it to the 1/3 power. And I need all of these parentheses that I'm putting in there. You will too.
Yeah, no, I can't figure out how to get my calculator into fraction mode too.
Well, notice my answer on my screen. 0.5555. What fraction is that?
Can you give me a second right now?
Sure.
I'm gonna try something else. Yeah, no. None of these things are working. Because I can't get it to convert.
Okay, you don't need to get it to convert, Bolton. Just put it in exactly like I've put it in, right here. Using all those parentheses too. Your answer should be the same as what you see on the screen.
What is that caret thing? What does that caret thing mean?
That's raising it to that exponent.
Ah.
That's what we're doing, is taking the cube root. So we're raising it to the 1/3 power.
Okay, 5/9.
There you go.
So that's the ratio.
That's the linear ratio. Okay, so let's erase that decimal and replace it with 5/9. Now what's the area ratio? Because what they're asking about is the area.
25/81.
Now set up the ratio that's going to let us solve for the volume. Oh, hold on a second here. What happened? Oh, I'm on the wrong problem. I gotta be. Oh no, yeah, we're on number 4. Sorry, I forgot where I was at for a moment. We are solving for area, right? They want the surface area of the larger ingot. So what?
Well, I'm finding a better volume ratio by just
No, they gave
cubing, by just cubing 5/9.
They gave us the volume ratio already.
But the volume ratio isn't super. It doesn't exactly work with the other two.
What do you mean by that?
I don't know. I just like it to be. I just like it to be the length ratio cubed.
You don't need it to be like that. That's a waste of effort to get it like that. Because all you had to do is put that into your calculator to get the linear ratio. Now we have an area ratio that's already reduced, and now we can solve the problem. If the surface area of the smaller is 200, well, then what ratio equation can I set up? I know the area ratio. I don't care about reducing that 500 over 2916. That's not a factor anymore. We're beyond that in this problem. The only thing we needed was the area ratio. And we've got it. 25/81. So what relationship relates 25/81 to what?
To 200/x.
Correct. And now you have a simple ratio problem to solve, cross-multiply it. But you understand, I don't need to simplify that. I've got to put it into a calculator anyway. Why go through the mental gymnastics of simplifying that? Has nothing to do with the problem. Once you have found the cube root of that to be 5/9, well, now you're off to the races. You don't care about the volume ratio anymore. You're done with it.
The surface area of the larger ingot is 248 inches squared.
Don't think so. Notice those two ratios are nowhere close. This is like a 1:3 ratio, and you gave me like a 4:5 ratio on the right side. Always do a ballpark check. Solve for x, cross multiply, and solve for x. What do you get? Should be in the area of 700.
What?
should be approximately 700.
I got 648.
There you go.
25 over 81 equals 200 over 648.
Okay, now you got the answer. All right. Yeah, spending your time trying to reduce this fraction that they gave you is wasted effort. It is not needed. You're not going to come up with the cube root of that on your own. You're going to use a calculator, always. Are you not?
Okay.
Yeah, so
Yeah,
why do we
but next picture.
What?
Next picture, I think.
Okay. The next question is on the next picture?
Mm-hmm.
Mm-hmm.
Well, I've already done the next problem because it was really easy. It was just solving for x.
Okay, hold on a second. Let me find, let's see. No, it's not this one. It was the one, it was on your first one, huh?
Mm-hmm.
Oh, I need,
It was that one, no.
all right.
This one should be so much easier.
Well, these others aren't hard. It doesn't get much easier than linear ratio, area ratio, and volume ratio. The only difficulty is you have to know how to get these cube roots from your calculator. In other words, you have to be able to take the cube root of this ratio, the volume ratio.
So I've already done 5, and x equals 5 3/5.
Doesn't look right.
Wait, no. No, I screwed up. Give me a second. Okay.
So what's your ratio? Equation. What's your ratio equation?
My ratio equation is that 14 over x equals 22 over 55.
All right. That's all I need to know, is that you know that. Okay, let's have a look at 6.
X equals 35. There we go.
On 6?
No, on 5.
On 5.
So wouldn't this be that x over 18 equals 20 over 30?
No, again, you're comparing a triangle with a trapezoid.
18 over 30 equals x over 20 then.
I don't think that's right. I think it's 18 is to 30 as x is to x plus 20.
Oh, yeah.
In other words, you keep making the mistake of comparing triangles to trapezoids. You can't do it. You got to compare this triangle to the big triangle. Well, the base of this triangle, so it's 18 is to x. We can certainly do that. 18 is to x as 30 is to x plus 20. Notice that gives me, when I cross multiply it, the same thing I got when I wrote it like that, even though they're different ratio equations. It's okay that both equations are valid, and notice that when I cross multiply, I'm looking at the same thing. But there's different ratios, and you have to understand which ratio you're using. That's the most important thing. But just be careful about comparing triangles to trapezoids. So that's a little tougher to solve because there's an x on both sides of the equation. You know how to solve that, don't you?
I got it. X equals 30.
What's x equal to? 30?
Yeah.
So
because what I got by cross multiplying was that 30x equals 18x plus 360 minus 18x. And then I got 12x equals 360 divided by 12x equals 30.
Yeah, that's the right answer. Okay. Now let's look at 7, right? Yeah.
ABC is similar to CA.
One second. Number 6 is the first time we've encountered the situation where we had the variable on both sides of the ratio equation. So 6 was definitely a degree up in difficulty. So Yansak's getting there. My last student, I said, what's wrong with Yansak? Because
Well, we had questions like this before.
all the problems were easy that she was giving me. I'm not used to easy problems from Yansak.
We've had questions like this on quizzes.
Okay. So on number 7, the bottom triangle is similar to the top triangle.
Okay, wouldn't that be x is to 12? Sorry, 12 is to x as 9 is to 18.
Well, we have to figure out which sides are corresponding. Well, I'm not positive which sides are corresponding yet.
You're right. It'd be 12 is to x as it'd be 9 is to x as 12 is to 18. I think.
Here's the way I figure out which are the corresponding sides. Notice the top triangle only has one obtuse angle. It's right there. Okay? So that angle is to y, as this obtuse angle is to 18. So 18 and y are the corresponding sides. 18 is to y. Now the other part, let's see, if I take my obtuse angle and I go to the left, obtuse angle goes to the left, these two angles are the same. These two angles here are the same, which means the ratio of their opposite sides are this same ratio. So what's on the right side of that equation?
What? Right now I'm solving for x.
Okay.
From what I read, AD is similar to BC, and DC is similar to AC.
Let me write these down because these are really hard for me to see. Y is similar to which side?
AB is similar to AC.
Okay, so Y is similar to 18, right? No, yeah, you're right. And X is similar. How'd you get the other? Okay, let me do it your way.
So what I found was that 9 was to x as 12 was to 18. So I reduced 12 over 18 to 2/3. And then, because that makes it just easier in terms of arithmetic. Then, doing that, I got 27, due to cross multiplication, I got 27 equals 2x, divided by 2, and x equals 13.5.
Let me give you a little trick here that can help on some of these problems. You may not need it, but it might come in handy when you get a more complicated problem. And that is
DST, draw separate triangles.
Right, and then start labeling them. I know that's 18, right? Because all I did was separate those. This is X, this is Y. So I can tell that that's an obtuse angle and that's an obtuse angle. So I know that 18 and Y are the corresponding sides to that triangle, right? So 18 and Y go together. And what goes with X? Is it 9 or 12, and how do you know?
9 goes with X because AD is similar to BC. is corresponding with BC,
Right.
sorry.
Okay, so the reason this is a little tough is because angles 1 and angle 2 are so close together that I can't tell which one's smaller. If I could tell which one was the smaller angle, then I would have no question whatsoever what went with 9, whether it was x, whether x goes with 9 or does x go with 12. Now, if I take this bigger triangle and I rotate it about 90 degrees clockwise, now I can see everything, right? In other words, here's what I'm saying, if I take this triangle and I draw it like this by rotating it to the right, well, this becomes y, this becomes 18, and this becomes x. And now they're oriented the same. And now I can tell the 18 goes with the y, the 9 goes with the 18, and the 12 goes with the x. You had the x going with the 9, I believe. See what I'm doing? I think we're going to get different answers. In other words, you've got to make sure that you are relating the proper corresponding side. By separating the two triangles like I did, and then rotating the right triangle so that it is oriented in the same way that the smaller triangle is, now it's really easy to match up corresponding sides. I know the y and the 18 are opposite the biggest angle, so they go together. And then I know that the 9's got to go with this 18 here. So the similarity ratio is 1 to 2, correct? So what's x?
Yes.
If the similarity ratio is 1 to 2, what does x have to be?
How is it 1 to 2?
Because the 9 goes with this 18. You see why? They're both the left side of the triangle. This 18 here.
How does it? If you look in the congruency statement.
Oh, I see what you did.
Sorry, if you look in the statement of similarity.
So ABC is similar to CAD.
Therefore, AD, the second two letters in the second one, would have to be similar to BC, the second two letters in the first one. Meaning 9 over x equals 12 over 18.
Hold on. So you're saying BC is similar to AD.
Yes.
So you're saying the x goes with the 9.
Well, I wouldn't say there's...
No, I get what you're saying, and I see the faultiness of my reasoning in what I did. I took this triangle after I separated it and I rotated it slightly counterclockwise, putting the x down here on the bottom, the 18 on the left, and the y on the right. But I should have flipped it. In other words, didn't require a rotation, it required a rotation and a flip, putting the x there and the 18 down there. And now the x goes with the 9, the 18 goes with the 12, and y is how much?
Y is 27.
Correct. Yeah.
And I also did 8.
Okay, well you pointed out a very valuable thing to me. And that is when it's difficult to line the triangles up properly, you should use the title of the triangle and the letters. I don't know why that's always something that's difficult for me to remember. I'm not sure why. I always try to do it pictorially. I try to do it by...
Hey, I tried to compare triangles with trapezoids, so
Actually, if you flip this triangle over the x side, then it will be oriented perfectly.
yeah.
And then you will have no problem comparing the x with the 9, but that's difficult. In other words, we have one obtuse angle there, and we have two acute angles. So the acute angles appear to be close to the same. So it's not easy to figure out the corresponding parts by looking at it. But you can figure them out. You can figure them out the way you did, which is to figure out which lines are similar. And you could tell the first two letters of this one have to be similar to the first two letters of the other one. That's why we know that the Y goes with this 18. And no, you did it properly. It was me that was mistaken on it.
Yeah. It was confusing for me, but also I think we're out of time.
We are. And in fact, I got your brother up next. So tell him I'll be there in a minute. I'll talk to you next week, Bolton.
Okay.
Bye-bye.